Welcome to the GobiWeb video training series. In this tutorial, we'll demonstrate how to carry out differential methylation analysis from bisulfite sequencing samples. For this tutorial, we will use the DNMT3B mouse transgenic RRBS dataset we used previously in the alignment tutorial. In this dataset, DNMT-B transgenic mice are induced, and these and DNA extracted from those mice and control samples, and 3 replicates of each group are sequenced using the reduced representation bisulfite sequencing protocol (RRBS). Those samples were then uploaded to GobiWeb and aligned using the last bisulfite alignment mode. In this tutorial, we'll compare methylation at the base level between the induced and control groups. So, to start, we navigate to the Actions menu and select Compare Groups of Samples. Our Compare Groups of Samples wizard will come up. We'll create a description for our job, DNMT3B, induced versus control, RBS. So then we select under analysis type, methylation analysis at base level resolution. And we know that the organism here is mouse. We select the MM9 genome, which is what we aligned against. We have 2 groups, the induced group versus the control group. Yes, type of analysis output format is methylation. Q value threshold, 0.05. So GobiWeb can output only the filtered set of sites that pass a particular Q value threshold. If you'd like to output all sites assayed, then set the Q value threshold to 1. If there are no hits that pass that Q value threshold, a minimum number of top hits can be reported. Minimum variation support. This parameter stipulates the amount, the coverage that you would like that supports each reported cytosine across all samples. So in this case, we have 2 groups with 3 samples in each case. That's 6 samples. So you would expect to see at least 35x across 6 samples. So if you have a minimum coverage threshold, let's say, for example, you want only sites that are at least 10x, and we have 6 samples, so you would change that to, say, 60x. For example. In this case, we do not want to call indels, so we leave this box unchecked. Gobi implements an empirical test for differential methylation between groups. You can estimate this p-value by clicking this box, empirical p-value. The p-value combination method, median, is the default, and this is the current recommended approach. This parameter, length of a fixed window, allows us to set a moving window across the genome in which we calculate the number of significant sites. So in this case, 1,000 base pairs. From the site under consideration to the preceding 1,000 base pairs, this is the number of significant sites. And significance is determined by the next parameter, significance threshold, to consider a site significant in the window. As you can see also, we can set up different GobiWeb users to share different jobs with, but we won't do that for the purposes of this tutorial. The next step is to define the first group. So you click that and the wizard takes you to the next configuration page. So we scroll down, so we label the group control. So here in our alignments, you can filter and search. Here I'm searching for a last alignment for these 3 samples. So here I select control, replicate 1, replicate 2, and replicate 3, and assign those to the group control. The next step is to define the second group. Group 2 is the induced DNMT3 TET-induced group. So again, I want to use the last alignment for this comparison. Version 2, 3 samples, assign those to group 2. The next step would be to define the comparison pairs. So if you had more than 2 groups, you could do multiple different comparisons. But in this case, I want to add a comparison pair, control versus induced. And the last step is to verify the setup. Yeah, this is your last chance to check your configuration. You check that everything is correct and you've set up everything correctly. You check the genome, the reference, the groups. You check that all the samples you want are in the correct group and that your thresholds have been set accurately. And saving this group of samples comparison configures this analysis to be run on the cluster. So a unique job tag is created for the job, and the job is submitted to the grid and begins running. Whilst the job is running, you can keep track of the progress that the job is making through the status history. When a new event occurs, it's dynamically updated in the status history, and you can continuously check back to see what the status of the job is. You can also refresh by clicking this double arrows on job status, and this will let you know the latest events for the job. Alternatively, you can check back on the status of a job at a later time by navigating to Browse, selecting Methylation Analysis. Here you look for the job using, for example, the description tag that you set up. Here's the job we set up earlier, the NMT3B induce versus control RRBS job. We select that job, double click, and this brings us back up to the results page. The top half of the results page shows details of how the job was configured. Here the job status shows that the job has been completed. Under completed analysis, on the left you're able to browse different results tables, and on the right you can download those same files that you can browse. Further down you have analysis plots. These are diagnostic plots about the samples. The first set shows read coverage across samples, and the second set looks at bisulfite conversion rates. So let's start with the bisulfite conversion rates. This plot shows the non-CpG context conversion rate for all samples in the analysis. Here we know we have 6 samples, and we see that for all 6 samples, the conversion rate is between 95 and 100%, which is good. For the coverage plots, we have one represented for each sample. On the x-axis, you have the coverage represented in log scale, and on the y-axis, we see the density of coverage across all samples. We see that for these 6 samples, we have fairly uniform coverage across our experiment. There are no sample outliers in terms of coverage. The majority of sites observed are at around 30x. So we use these plots to provide a diagnostic overview of our samples. Under completed analysis, you can download a methylation VCF file together with its index file. This file can be used to analyze the data using such tools as VCF tools. You can also load this VCF file into IGV, the Integrated Genomics Viewer, for visualization. You can download a file that is used to generate these plots that shows the coverage for each sample, as well as the conversion rates, bisulfite conversion rates, and non-conversion rate by context. A useful feature of GobiWeb is the ability to browse your table of results. For methylation analysis at the base level, the table of statistics is a tabular form of the VCF file. So we click Browse. This takes us to the results page. This is a table, like I said, that shows a tabular view of the VCF file. Each row represents a single genomic position, and we have a wealth of data for that genomic position, including CpG context, statistics for differential methylation between groups, estimates of methylation rates for each group. So this table can be quite overwhelming. So in GobiWeb, what you can do is filter this table and download a desired subset of it. So let's show you an example of this. So below the main table, you have this menu, all columns and visible columns. So all in all, this table is 120 columns, but this subset view is only showing 30 of those. So you can either remove all the columns, So you move the visible columns into the all columns side and click show or hide. So then I can build my table dynamically using the fields that I would like. So I'll set up the table. So let's see, we want the chromosome, we want position information, we want strand and context. And then I'd like to see a methylation rate summary for the groups, induced group and control group. So I look for those columns here. So that would be info column, methylation rate control, info column, methylation rate induced. Okay, I select those columns, select them to the visible, and if I want to show the first few rows of that table, I click show or hide columns. So you see our table now, we're only showing those selected columns for the entire data set. Another thing we might be interested in is which are those cytosines in the genome that are differentially methylated between control and induced. We have two tests in GobiWeb. We have the Fisher's exact test for the differences between the two groups, and we also have an empirical p-value test. So let's say I was interested in using the Fisher test. So I could search the columns and see which columns have a Fisher p-value, and here we have the corrected Fisher p-value for the comparison control versus induced. So I select that column, again click show or hide, and now at the end of that table we see that column has been added. So we want to download a subset of the table, that is the significant sites. So filter, let's say I want my threshold to be 0.05. I filter this table for the sites that are less, with a Fisher p corrected p-value of less than 0.05. See, the table is updated, and we see that we have 303,346 sites. You can filter the table even further by limiting to, say, for example, only those sites that are on chromosome 2. So we have 24,763 entries in the table now. If you're satisfied with your filtering, you can download the subset of interest as a TSV file using this button on the top right-hand corner. This concludes our tutorial on differential methylation analysis at the base level. For more information, please visit our website at gobiweb.compagnonlab.org.